When we look at the night sky, it's easy to imagine space as a perfect vacuum, a silent, empty region between the stars. From far away, that seems true. Stars appear isolated. The distances are enormous. And when we zoom out to the scale of the Milky Way, it feels like nothing exists between these points of light. Just a black void. But that picture is incomplete, because the space between stars isn't empty. The interstellar medium, the ISM, is the material that fills the galaxy and the space between stars. And even though its density is incredibly low, it behaves like a fluid, or a liquid, or gas. A very unusual fluid. Most of the interstellar space medium is hydrogen, the simplest and most abundant element in the universe. It appears in different forms. There is neutral hydrogen, a cold and visible gas. There is ionized hydrogen, hydrogen gas found glowing around hot stars. And finally, molecular hydrogen, denoted as H2. It is found in dense, cold clouds where stars form. In the interstellar space medium, there's also helium, which makes up about 10% of the ISM, trace heavier elements like carbon, oxygen, nitrogen, silicon, and iron. And in the interstellar space medium, there is dust grains, made of silicates, carbons, and ices. Even though the density is extremely low, sometimes just a few atoms per cubic centimeter, this mixture behaves like a fluid on large scales. The interstellar space medium is shaped by radiation, stellar winds, magnetic fields, and shock waves from supernovae. These forces carve out bubbles, filaments, and cavities, i.e., fluid phenomena. Cold regions collapse into dense molecular clouds. Hot regions expand and push material outward. And hydrogen is at the center of this entire cycle. Stars form from molecular hydrogen. Stars fuse hydrogen into helium and more heavier elements. And when massive stars die, they explode as a supernova, returning heavier elements back into this hydrogen sea, slowly enriching the galaxy over billions of years. The interstellar space medium is not static. It's a dynamic, turbulent, and constantly reshaped by the life cycle of stars. This strange, low-density hydrogen fluid doesn't just shape the physical structure of galaxies. It is relevant to the future of interstellar travel. For spacecraft moving between stars, the interstellar space medium becomes a real engineered environment. There are 4 factors here. Number 1, hydrogen gas matters at high speed. At relativistic speeds, approaching the speed of light, even a few hydrogen atoms per cubic centimeter create drag, heating, ionization effects, and plasma interactions. A vehicle traveling at 10 to 20% the speed of light would experience the interstellar space medium as a thin but continuous hydrogen wind. The second factor is dust grains. Dust grains are a major hazard. Micron-sized dust particles, tiny bits of carbon and silicate, become dangerous projectiles at high velocity. They can erode shielding, puncture thin spacecraft structures, and generate plasma flashes on impact. Dust grains and dust collisions are one of the biggest engineering challenges for interstellar probes. The third factor is the interstellar space medium is electrically active. The ISM isn't just neutral gas and dust. Some regions are filled with ionized hydrogen, which means there are free electrons and protons, and threaded with weak but widespread magnetic fields. For a spacecraft, this means the environment isn't electrically quiet and has a high potential to damage the spacecraft. Charged particles in magnetic fields can interfere with electronics, build up static charge, and create radiation exposure over long distances. So, interstellar vehicles need radiation shielding, hardened systems like unique spacecraft structures, and sometimes magnetic or plasma-based protection concepts. Travel through the interstellar space medium, the ISM, is flying through a charged, magnetized medium. The fourth factor is the ISM defines interstellar routes. Some regions of the galaxy are dense and dusty, therefore slow, hazardous to travel through. Other regions are hot and ionized, therefore high radiation. And finally, other regions are diffuse and calm, meaning there is less fluid collisions. Diffuse and calm regions of the ISM are ideal for interstellar travel and interstellar space missions. The interstellar space medium is the ocean between the stars, and future spacecraft will have to navigate it with the same care that ships navigate currents and storms today. The space between stars is not empty. It's a vast dynamic fluid that shapes galaxies and will shape the engineering of interstellar travel.